circles. We're going to do a couple of video lectures on circles, and this first one's going to deal with the standard form of the equation of a circle. So our objective here, as stated, write the standard form of the equation of a circle. We're also going to look a little bit, we're going to look at how to graph a circle, or a good approximation for the circle using the TI calculator. Okay, a couple things we know about, one thing we know previously that'll help us with this lesson. We know from a previous video lecture the distance formula. And we know that the distance formula comes from the Pythagorean theorem. Okay, and the distance formula says that the distance between 2 points is equal to the square root of the change in the x coordinates squared plus the change in the y coordinates squared. Okay, so we're going to make use of that here in just a moment. Let's define what a circle is as we talk about it algebraically. A circle is a set of points in the xy plane that are a fixed distance r, excuse me, which is the radius, from a fixed point, hk, which is the center. Okay, see if you can forgive me for my hand drawing here. I drew the xy plane, I drew a center, and I labeled it hk. I drew a radius, and I did the best I could to make sure that that distance from the center was always the same to create a circle. It's close, it's not perfect, but it's close. And every point, any point out here we'll call xy. Okay, so this distance, this is a fixed distance. The distance from here to here is always equal to r. Let's use our distance formula from above here. Let's use our distance formula. So the distance, which is r in this case, r is equal to the square root. Well, it's the change in the x coordinates. So I'll do from x minus h, the quantity squared. The x coordinate of this one is x, the x coordinate of this one is h. And I'll add to that the difference in the y coordinates, which in this case is y minus k, and of course the quantity squared. So I've used this exact formula here that we saw earlier with distance, and because I have a center at hk, because one of my points is hk is going to be subtracted, and because the distance is equal to r, you have r equals to that as opposed to just the generic distance. Let's do a bit of math with this. Let's square both sides. Okay, and I come up with r squared, and of course squaring is the inverse operation of square root, so that'll undo the square root. R squared equals x minus h, the quantity squared, plus y minus k, the quantity squared. And I'm going to write this, I'm just going to reverse how it's written. Okay, this gives me that x minus h, the quantity squared, plus y minus k, the quantity squared, equals r squared. And there you have it. This is the standard form, okay? The standard form of the equation of a circle, right there, okay? And now let's remember, okay, we noted that hk is our center, okay? hk is the center, because that's how we created this. H and K was our center, and R is equal to the radius. Okay, so that's what you want to know right there. I just derived it for you. Okay, but it's x minus the x coordinate of the center, the quantity squared, plus y minus the y coordinate of the center, we're calling k, the quantity squared, equals the radius squared. This piece, radius squared, is often where students they often forget that the radius is squared at the end here. Okay, let's take one note of something. Let's shift this up just a touch. Let's note one thing that's worth noting. If the center is at 0, 0, if the center is at the origin, okay, then we have x minus the x-coordinate of the center plus y minus the y-coordinate of the center is equal to the radius squared. And of course, x minus 0 squared is x squared. Y minus 0 squared is y squared equals r squared. So when the center is at the origin, the standard form of the equation gets rather nice and simple. Looks just like that. Okay, let's take a look at an example, and let's make use of our graphing calculators to see it. So example 1 here, write the standard form of the equation of the circle with radius 5, and the center will have located at -3, 6. So it'll be in quadrant number 2. Okay? Quadrant 2, of course, has a negative x coordinate and a positive y coordinate. Okay? So we want to write the standard form of the equation of the circle with radius 5 and a center at the point -3, 6. Well, the standard form is x minus h, the quantity squared, plus y minus k, the quantity squared, equals the radius squared. Okay, so x minus the x coordinate of the center. Well, the x coordinate is -3. So x minus -3 is x plus 3. Okay, that's another place where students will get lost here. We are subtracting a negative, so it's x plus 3. And then y minus the y coordinate of the center. Well, the y coordinate of the center is 6, so it's simply y minus 6 squared. The radius is 5, square it, and get 25. And there you have it. That's your answer. That is the standard form of the equation of the circle with radius 5 and center at -3, 6. That's it right there. Okay, let's graph it. So to graph this, okay, our calculator says we need y equals. Okay, so we need to solve for y. Okay, we can do this. Okay, I'm going to rewrite this equation. X plus 3, the quantity squared, plus y minus 6, the quantity squared, equals 25. I got to solve for that variable right there. Let's move this first. I'm going to subtract the quantity x plus 3 squared from both sides. Okay, that leaves me with, on the left, the quantity y minus 6 squared, and on the right, I'm just going to write down 25 minus the quantity x plus 3 squared. Okay, again, I'm still trying to solve for y. Now I got to undo this squaring that's going on. Okay, let's square root both sides. Okay, so that's, of course, square root is the inverse operation of squaring, so that undoes it. I'm left with y minus 6. And when you take the square root, you need to account for the fact that there are two possibilities that when they're squared, give you the same number. So this is plus or minus the square root of 25 minus the quantity x plus 3 squared. That's what people will miss, is right here. Okay, so now I'm going to, again, I got to solve for y. So I'm going to add 6 to both sides. And I finally have solved for y. 6 plus or minus the square root of 25 minus x plus 3, the quantity squared. Okay, make up a touch here. So we can see a little bit better. So here we are. Okay, well, we know there are two possibilities here. There's 6 plus and there's 6 minus. So we want to do y1 as equal to 6 plus the square root of this mess, 25 minus the quantity x plus 3 squared. And we want to do y2 as 6 minus 25 minus x plus 3, the quantity squared. What we're going to see is this is the upper half of the circle, and this is the, whoops, I'm having a difficulty spelling lower. This is the lower half of the circle. Let's take a look. I'm going to slide this up so I think we can see, there we go, the top of the page there. Let's go into our calculator and let's graph this one. So, okay, I'm in my calculator, y equals, okay, the upper half is 6 plus the square root, 25 minus x plus 3, the quantity squared. Okay, and then let's come down and do the lower half, which is 6 minus the square root, 25 minus the quantity x plus 3 squared, and then let's press graph. You'll note I'm in the standard window, and there's what you get. And it looks a bit more like a football. Okay, well, we know how to fix that football look. We know that because we have a rectangular screen that it's not going to give us the, exactly how it should look. Let's go to our zoom and let's press square, number 5 again. We did this in the previous video, and that gives you a better circle. But we need to kind of fix our axes so we can see the whole thing. It looks like the y can start at 0, and you go the y higher. So let's go to the window. Let's just leave the x alone. The y has to go higher, so we'll start it at 0, and we'll go up to, I don't know, let's go up to 15. And now let's graph it. And there's the top half, and there's the bottom half. I think I went to make sure my zoom is in square. I might have lost that when I did that. That's better. A little bit of disjointed. It's never going to fully connect. That has to do kind of with the resolution of the calculator, as well as the fact that coming up with those exact points on the horizontal line, the calculator can't do. But it does give you a pretty good sense of what that circle should look like. And we know that at -3, 6, if I go over -3 and I go up 6, I can pretty much plot my center right in the middle there and see it. So there you have it, the standard form of an equation, the standard form of the equation of a circle, x minus h, the quantity squared, plus y minus k, the quantity squared, equals r squared, where the point hk is the center and r is the radius.